All right. We're actually going to do a pretty short video. Sorry, I know a little glare there. A pretty short video today. Do kind of an intro to thinking and problem solving. Some of it would be simple stuff that we've gone over before, and maybe a couple new terms here and there. But all right, so hopping in. This is thinking and problem solving, and eventually we'll get to language in this unit. So real quick, Thorndike, remember Thorndike came up with the law of effect, which basically just means at some point in time, you're going to figure stuff out, right? So he threw the cat in the maze, and the first time it took the cat a long time to get to the cheese at the end, or the rat or whatever. And over time, the more and more trial and error the cat was allowed to have, the faster its times got to figure out the end of the tunnel, right? So, or maze, sorry. So without trying to teach it the maze, without the cat trying to read about the maze or see the maze from a different angle or anything like that, being trained really, Thorndike would just continuously release this rat, release this mouse, and over time documented that they learned, right? They've learned from their mistakes, their trial and error. Thorndike's law of effect. Wolfgang Kohler, he had this concept of insight learning. It's kind of known as the aha moment, that at certain points as we are learning, as we are being taught, as we are thinking, we come across these aha moments, these light bulb moments where we realize, hey, I just figured it out, right? That we realized we just made the important connection. We reached the important conclusion. And then metacognition, remember that's kind of like introspection, thinking about one's own thoughts. Being able to rationalize or justify or explain one's own thoughts. So remember, you missed something on a test, and instead of you missing it because you didn't know the answer, you are able to tell and explain, rationalize, justify to the teacher why it was you chose the answer you chose. Okay, algorithm versus heuristic. Okay, algorithm versus heuristic. So algorithm is it's like a recipe. It's step by step. It's methodical. It's the opposite of just winging it, right? So algorithm, you guys probably seen those like tied to computers and coding and stuff like that. It's process oriented. It is about doing step one, then step two, then step three. It's like a manual. It's the scientific method. It's very well thought out. Okay. Heuristics is going to be more like finding a shortcut, doing something the first way you could possibly do it. Kind of more along the lines of common sense, maybe street smarts, right? Rather than following what the procedure is, the whatever the manual says, the how-to guide says. It is more about results, right? So algorithm, if I'm building some new toy house for my kids, the algorithm, I follow the manual. I read the book. I have the procedure, the pamphlet, the guidelines right there with me, and I follow it exactly how it's supposed to be done. Heuristic is more, okay, I see the picture on the box. I know how it's supposed to be. Let's see if I can't get to it as quickly as I can. Maybe I watch a YouTube video. It's all about results, okay? So heuristics, informal thinking, fast and simple, can lead to errors, but it can also be right. It's like another way to think of it would be like in calc or algebra or whatever math class. Algorithm would be showing your work, right? Where you are step by step. I am solving this algebra problem. Here is my work. I drew it out for you. Boom. And the more heuristic way would be answering it, getting to it however you need to get to it, but not showing your work, right? You did not do some kind of scientific method, some kind of algebraic method, step by step. Again, heuristic. If I ask you how to get from my house to, Pleasant Plains High School, algorithm would be, probably following the directions, step A, step B on, what's it called on your phone? Maps, Apple Maps, Google Maps, whatever it is. And, heuristic would be more like, well, I know Pleasant Plains is over there by Veterans, so I'm going to take my typical efficient way to Veterans and then figure it out from there. Okay, so schema. This is actually from Jean Piaget, Piaget. So schema. Schema is very unique to yourself. It's your own personal way of thinking. It's your own mental set, right? So schema and mental set. It's your own unique subjective perspective or way of thinking, right? So some of us are very abstract, critical thinkers. Some of us are, hey, if you give me a pamphlet, if you give me a guideline on how to make something, I can do it, right? But if you don't, then I'm not very good at it. Some of us might be able to do puzzles, without having seen what the end picture looks like, right? We have that kind of schema. We have that mental set. Whereas others of us, even if you have the box in front of me, even if you're playing some kind of how-to guideline for me to listen to, I can't do a puzzle, right? Script is it's like a prediction, okay? So a script is basically going to be your thought process, right? A script in your head, your thought process, your prediction of how something will play out. And then mental models. Mental models are basically just kind of assumptions of how things work, right? When you see me holding a brick, you think, oh, that weighs a few pounds. That's kind of heavy. It's hard to throw. It's going to hurt if you come into contact with it. But it's an assumption, right? You're not holding the brick. You're not feeling it. You're not weighing it in your own hands. So there's a chance that brick in my hand is made of foam, right? It's not even a real brick. So mental models are just these assumptions of what we see or what we hear, but they're just assumptions, right? So they can be wrong as well. Okay, so formal reasoning, slow thinking, methodical, checklist, step-by-step. Formal reasoning is going to be under the algorithm umbrella. So formal reasoning, again, you are trying to be accurate. You are trying not to just be right, but know that you are right, being able to prove that you are right, right? You took a step-by-step process. You use a checklist or a how-to guideline on how to figure something out, right? It's going to be kind of like bottom-up processing, bottom-up thinking, where you are thinking about the details, not just the overall picture, but you are wanting to make sure all aspects are covered. Intrinsic motivation, you guys probably remember this, intrinsic versus extrinsic. So intrinsic, inner, and then extrinsic, ex, outside of, or exited, Intrinsic is going to be you are motivated by something inside of you, right? Internal forces. So something internally is driving you to do things well, right? To succeed. Internal motivation, intrinsic motivation. You don't need a gold star. You don't need an A. You just want to be the best you can be, the best version you can be, right? Intrinsic motivation. Extrinsic, externally motivated, meaning you need a gold star to do your homework, right? You need outside forces like punishments or groundings to keep a clean room. You need a shiny medal or a trophy to try hard in sports, okay? There's something called the over-justification effect. That is the belief in, and some of you guys might buy into this kind of participation trophy idea, but over-justification effect. It's this belief that if you are continuously rewarded, it's actually going to bring down your intrinsic motivation, right? So we're kind of looking at that with different ways of reinforcement, where if you positively reinforce someone continuously, right, very often, then their intrinsic motivation is going to take a hit, right? So there's probably not going to be much of a balance there between inner and external. So this if you are over-justified, if you are over-rewarded, you will grow accustomed to that, and you will lose inside motivation. You will lose intrinsic motivation. So when tasks are thrown your way, when assignments are thrown your way, when competitions are thrown your way, and there's not a trophy, extra credit, money at the end of it, then you won't try as hard. Okay, divergent thinking versus convergent thinking. So divergent thinking, that's kind of divergent is going to be more like creative thinking, kind of thinking outside the box, trying to find multiple solutions, thinking of many solutions, right? Exploring multiple possibilities. Something that goes along with that is lateral thinking. Again, lateral thinking is, here's some possibilities, And lateral, okay, let's go to the side. Is there anything outside of the box? Any other solutions, you know, that might seem weird but might work as well. Convergent thinking is going to be choosing the most practical, the most efficient solution, right? So here's a list of possibilities. Here's a list of solutions. You would choose, convergent thinking would choose the most efficient, right? The most practical of those. This guy in the video told kind of a cool story. So a semi truck is driving under an overpass, right? Let's say the overpass is 14 feet. And the semi truck was 14 and a half feet or 15 feet high, and boom, hits the overpass. Well, you got construction workers coming out, you've got police coming out, you've got city engineers coming out, and they're all trying to figure out, well, what do we do with this truck? It's stuck underneath the overpass. How are we going to get it out? And, you know, they're all trying to come up with all these different solutions and doing physics and, you know, difficult calculations and stuff. And a little boy comes across on his bike and he goes, why don't you guys just let all the air out of the tires and then pull it out? And he had the most practical solution, right? He had the simplest solution. And convergent thinking is really just about being efficient, right? Being practical. Occam's razor. Some of you guys might have heard of this before, but Occam's razor basically is going to say when you come across a problem, right? When you come across the predicament, whatever is the simplest solution is the best solution, right? Another way you could think, eliminate as many assumptions as possible, right? So when you come across a problem, when you come across something you need to fix, the more assumptions you make, right? The more angles you try to approach something from, the more variables that will come into play, and the more overthinking will come into play, and the more errors you might create for yourself. So Occam's razor is just saying, keep it simple, right? The simplest solution is probably the best solution. If you complicate it, you're just going to get yourself into more trouble. Okay, so that's where I kind of want to stop. So just kind of an intro to thinking and problem solving. Again, we'll get into a little bit more later on, and we'll also with this kind of 2-3 part series of videos, we'll get into language. All right.